Well, hello pre-calculus students and seekers of truth. We will continue our study of parametric equation applications, this time again with an example that does not use motion. And from the previous video, we've done part A and C, and let us return now to part B. Find an equation that relates the temperature to the units of ice cream sold. Well, if we look at this table here, the temperature, right, and the units of ice cream sold seem like they don't have, they're not related at all. I forgot the temperature was, our variable was going to be F, sunscreen, our variable was S, okay? But rest assured we could solve and figure out the answer to part B, find that equation, by actually using the two equations we found in parts A and C. And you can, so let's start with this equation here that, and again, we are trying to relate F, that's the temperature, and I. Okay. So that has the same effect of us using the two equations that we already have, and we want to eliminate S. So that's not too hard to do. We take this equation, S plus 1 squared, but instead of writing S, I'm going to leave that alone. I'm just going to say blank plus 1 squared equals I. And from our previous work, we know that S is equal to F minus 67. So we can make that substitution here. So this is F minus 67 plus 1 quantity squared equals I. Right? And so let's simplify all of that. And this will give us our final answer being F minus 66 quantity squared is equal to I. All right. And you see this works out for us quite well, and if we test this we can see 72 minus 66 is 6 squared is 36. 73 minus 66 is 7. 67 minus 66 is 1 squared. Okay. And let us continue the problem here. So for of temperature, sunscreen, and ice cream units, what is the best choice for the parameter? And best choice here is somewhat subjective, right? It's not clear how we define best, but at least from what the table we're given, I would say that temperature is a good parameter, okay? Temperature, which was our variable F, okay? Now the reason that's a good parameter is because it's the change in temperature that causes the change in ice cream sales and sunscreen sales, right? So, you know, as it gets hotter, if we scroll back to the top here, as it gets hotter outside, you know, if you go from 67 to 70, we sell more bottles of sunscreen and we sell more units of ice cream. As we get up to 73 degrees, we sell some more bottles of sunscreen and we sell some more ice cream. It's not as though if we sell lots of ice cream, we're going to change the temperature of the atmosphere. And it's not as though somehow that we change sunscreen, we sell more sunscreen, we change the temperature. You know, it's the temperature that causes the other ones. Okay. Now the other equations are still useful. For example, part C here, the relation between sunscreen and ice cream. This tells me that if I sell some more sunscreen, I need to stock up a lot more on the ice cream, right? Regardless of what I know about the temperature. Now finally, do any of our equations require restriction, and why? Well, yeah, our restriction needs to be that F has to be at least 67 degrees. The temperature has to at least be 67 degrees for any of this to apply. Otherwise, we get some nonsensical results. Okay, so if F was less than 67, that would mean we get like a negative amount of sunscreen, for example. So at least one of the reasons is, like, you know, if F is less than 67, right, then the amount of sunscreen that we get would be less than 0, which is kind of nonsense. This is sort of like saying if the temperature drops below 67 degrees, people are going to start showing up to the shop to give us sunscreen, which again doesn't truly make any sense. Okay, so we can see here that, you know, with these three variables, I've simplified the numbers so that we could solve all of this, but so that we could figure out some of the patterns here. But the general idea is that we have three variables that are related to each other in some way, shape, and form. And it works in the same way that a parametric equation works, except that we have to think a little bit more about what the parameter is. In our motion examples, the parameter is always time. Here, depends on the context, the situation, the parameter might be something else. All right, so I want to make one quick acknowledgement to Mr. Eddie Wu, who works in Australia, and he was the originator of this example. But I put this into a video here, and hopefully this is helpful to students everywhere. As always, thank you for watching. Work hard, ask questions when you need it, and have a wonderful day.